Look at section 2, sampling and collecting data. Also, for these first couple sections, make sure you're looking at the book and just reading through what it says and about organizing data and collecting data, that kind of stuff. And read the topic outline. What I mean by that, it's really just an overview of the concepts. Some very very important concepts, but nothing specific. I'll ask you directly. We're going to be using these to describe things in the vocabulary. So population versus sample, we've already done that. Population is the set you're looking at in its entirety, and it is often the problem occurs is you look at this population, say like Chaffey College students, and then people might hear that and then extrapolate to other populations. And that's statistically completely false, completely invalid. So you could only assume things about something that's inside the population, statistically speaking. So that's a common fallacy or something that's not valid logically when you extrapolate outside the population in question. Now, within a population, and sometimes it's called the universe. Forgot to mention that earlier. So the universe is another way of saying population. I haven't seen it a lot in the books, but that's sometimes you say, okay, the universe is this, which is like the population. And then you extrapolate, you do things about that. So we won't really use that term, but so sampling techniques within the population, I want to just go over briefly, and a couple research ideas. So there's a couple sections in that about sampling methods, and so one of them, sometimes they're good, sometimes they're not. It just depends. If you had just different items like this, pretend you had this sort of thing. You get the idea here in a second that it's not very good, but you could do something like this. So if you have that, if that's your, just assume this is bigger, right? I don't want to sit here and write down a bunch of stuff. So if you had this as your population, which you could picture it all inside here, then how do you sample those? Well, you could, and they're objects, right? You could label them as put numbers on them, 2, 3, 4, like this. You can see there are duplicate things, so that in itself might be a problem. But there's still this, it's like the same object, but I just listed them out. And then you can do a random number generator and select, however many of those. So pretend there's 80 of them or something. You could do a random number generator and select them. And then you'd have, 3, 16, 8, 15, 80. Okay. Pretend that's random, and I don't think it's not. Anytime you make something up, it isn't random because you are interpreting it. So that could be the numbers. That's one way of doing it. You could pick every fourth one, something like that. So there's different ways of doing it. We are not going to be concerned about that. That is we are, but those are research methods, and those have to be valid. The key for us is that it's a random sample, that is truly random. So as we go through everything, we are making that assumption that it is random. All right, so there'll be examples in the book and homework that talk about what's random, what's not. One of the classic, so when you look at like the lottery, for example, you have all the little balls floating around and air going in them like this. They're all numbered, right? And then they start coming out the tube. That's like about as random as you're going to get, assuming that all the spheres in there are the same kind of dimension and there's nothing about them that's going to make them come out sooner than the other one. Then that's a random experiment. Okay, and then they come out the thing, and you read off the numbers, right? So that is fairly random way to do it. Okay. All right. So then, so look into that. Read more about the random sampling. I'm not going to get into all that stuff in detail. I want to get to the math, frankly. What else do I want to go over? You get into, okay, so let's talk a little bit about experimental design. There's two basic situations when you're doing a study. One of them is observable. So observable studies. And the other one is experimental. So what we mostly do in education is research, that is, that I'm used to doing or analyzing or viewing or whatever, is the observable studies, which is you are just looking at what's happening in front of you, and you observe them and run data on them. So you are just looking at success rates, you're looking at grade point averages, maybe for my own classes, how they're doing on particular tests, particular exam questions. I'm observing the situation and then running a experiment or running a example on it. Excuse me. So, or that is the study is observing what's happening. Now, experimental studies are where you design the experiment itself. So that can happen in education. I did one actually for my dissertation, and it was on multivariable calculus. And one class I used a computer algebra system and visualization techniques to plot things. Because in that class, everything's like three-dimensional, like that's where you get into. And then I just taught another class that I didn't use it. And the results themselves were tiny. Like I basically had a handful of students. I couldn't really generate any conclusions. It's really about the design and how you do it. It's the practice of doing it is what you end up looking at. And so that is basically a concept of experimental design where I had two situations going on. So I had the losing the terms here in my mind. It's the yeah, so basically in that case, what I had was I had one group, so you had group 1 and group 2, and one group gets what you call the treatment, which was essentially the computer package, and one group does not. And then you observe if there's a difference. So is there a difference in whatever you're looking at? So I might have looked at, I actually did a exam, like a validated exam. I looked at my test scores and things like that, and I looked to see if there's a statistical difference. Okay, so that's was an experimental design. It wasn't just observation, where you just observe what's happening. That's often what happens in psychology. In medicine, you have to have very, very well defined, concrete ways of doing the studies. Unfortunately, these days it's not happening as much as it should to get to give recommendations and things like that. It's I didn't see that a lot in the last number of years of actual good statistics and experiments running. But that's what you might do. All right, so research studies, oops, I forgot the B, sorry, observable studies, experimental studies. All right, so then a couple things, some other words to look at to talk about is causation versus correlation. Or association. So, causation versus correlation is a very important distinction to make, and I'll get more into that as we get to the concept of correlation. We actually look at the data. Is it correlated? So you talk about data being correlated versus it causing it. So here's an example. Let's see. Well, excuse me. So one concept might be students who take summer classes have get higher grades than the regular classes. So that's what we would say is correlated. This is actually true. So students who take summer classes, the grade point average is often higher than the normal session. So what conclusions can you draw from that? So there's a correlation of that. So what would be correlated? Well, temperature might be correlated. It's warmer in the summer. Is it temperature that makes the difference? Because it's a correlation. Higher temperatures per day imply higher grades. Or I should say, they're correlated. But is that the cause of it? Well, of course it's not the cause of it. That's not correlated. Or I'm sorry, that's not the causation of it. It's not the reason for it. The reason for it is probably just motivation. You're in summer and you want to get ahead, and students who do that are often more motivated. So that's probably more what the causation is. But you could correlate all kinds of things at being summer, like because it's you could correlate that. I don't know. What else happens in the summer? It's like there's less maybe colds. You don't have as many colds, or not as many flu symptoms in the summer. So people are at school more. So you you have a better chance of being successful. Maybe that's correlated. Because summer, we all kind of agree you don't get as sick in the summer as you do in the winter. So maybe it's summer that is less people are sick. Is that the causation? Probably not. That's not probably it. There's probably not enough people that are sick to make a difference in the winter. So these are the things that you can argue causation, but there's really just a correlation, but we don't really know why. The variable there's a word for that too. There's a word for confounding and lurking variables. So confounding variables or lurking variables. So confounding variables are basically variables that influence an experiment that are not tested. So it's like there are other variables that might have changed the outcome. So that example could be, let's just take the summer thing, for example. So the confounding variable, so I'm making the claim there's a correlation between the temperature outside and that it's warmer, here in Southern California, and therefore you get better grades. So temperature is causing higher grades. Higher temperatures cause higher grades. Well, that's the correlation, but we clearly know that's not the causation. That's silly. So the confounding variable is something that we didn't test. That's in between. So we'll talk more about those as they come up as we design things and talk about things. But again, as I mentioned earlier, those aspects are really more about research design, which is the next course after this. So after these first few videos, we'll get into more of the math of it. And that's really what we're focusing on. We're going to focus on the math concepts and some of the equations, and just we're going to be making the assumptions that these are all done right, essentially. And we'll talk a little bit more about it as we go. And I need you to spend some more time in the books, reading through them, just getting a feel for all this stuff. This isn't really the direction I want to spend a lot of time on. Okay. Let's see what else I can tell you here. Let's go back to our notes here. So we did go over populations, sampling, random sampling, statistic, already talked about that, experimental design, a little bit about that, and we talked about that. So we hit most of those, and then now spend some time in each of those chapters reading over. You don't need to do both of those, just pick one. When we get into the homework, then it'll be very specific. Right now, I just want you to read over what the book says. Okay, and then next, we'll get into section 3. Thank you.